Hello everyone, welcome to the class. Today we will talk about semaphore. What's a semaphore? How to use it? So far we talk about we covered like how to detect the sharing, unintended sharing, like on your program. So we know we can check what's a sharing. And for the source code, if we found there's a sharing, we know how to use critical like a zone, like a critical section, like a analysis to check what's a critical zone in your source code. Okay, so after you got the critical zone, how we actually protect it? How we like avoid this like a race condition? This is for today's topic. Let's see the example we showed in other videos. In these videos, we already know this is the critical zone, CNT plus plus. And if we don't protect it correctly, we will get race condition. So, but why? Like how? How we protect it? So this is for today's topic. We will talk about the semaphore. So what's a semaphore? The semaphore is, you can imagine a semaphore is a very special variable. So we create a semaphore. So we define a semaphore here and we pass it into an initialization. So we give a number. We give a number of the semaphore. And for example, we give a number 3 for the semaphore. And in this case, if you use same weight, you will decrease this value. You will decrease the value. So we will change the value of semaphore minus minus. We will like decrease it. And if we use pause, we will change the semaphore to plus plus, something like this. Okay, so which means if we can like handle the semaphore minus minus plus plus, maybe we can use this value to detect like do we want to like stop? Does the thread is allowed to be enter this critical zone? If so, what happens if the thread cannot like come into the critical zone? So it actually there's a source code here. If semaphore equal 0, you should not go into a critical zone. So actually, this is something we have a infinite loop while. So you can see while the semaphore equal to 0, we should not go into this critical zone. If the semaphore is not equal to 0, then we can run this send minus minus. The concept of this one is if we initialize a value of 3, we have 3 key here. Okay, so the first thread come here. The first thread come here is take 1 key from the table and enter it into the door. So we have a noon here. We have a noon here. So which this is the critical zone. Then the second thread come here. The second thread get the key and go into this critical zone. And the third one come here, got the key and enter the critical zone. Okay, the fourth thread. So right now we have a thread A, B, C inside this critical zone. But right now the thread D comes here, there's no key. So if there's no key, you just will stop there, do some infinite loop, like while loop, stop there until, for example, the B, thread B is finished, the thread B go out and return the key back to the table. Then the D can take the key from the table and enter into this critical zone. This is the idea to use the semaphore. So if you have a semaphore, you can control how many threads you are allowed to go into the critical zone. So in this case we only have 2 threads, and no matter like how many threads enter to this critical zone will cause a problem. So if we want to solve this problem, this question, how can we do? We just initialize the key, just 1 key. So actually, this is not so difficult. We just initialize as 1 key. In this case, only 1 thread can take a key into this critical zone. If the A take a key going to a critical zone, then the B need to wait outside of the critical zone. If you have more than 1 thread, you have like multiple threads, they all need to stop outside of this door to wait for the key. So this is the idea, use a semaphore to protect your critical zone. And usually when we use a binary semaphore, what's a binary semaphore means you assign the value is 1, which means only 1 key. In this case, we can give another name, it's called mutex. So in the future, you will see actually there's a mutex implementation way to protect this critical zone. The semaphore is not the only way to protect this. Actually, there's a couple ways you can do, and one way is called mutex. But in this video, we only talk about a semaphore. The semaphore, you can imagine that you just initialize how many keys you want. How many keys? Why you need so many keys? Because you might want to allow more than one thread going to a critical zone. You want like maybe 3 threads going to a critical zone. Because 3 threads might not cause any problem in the critical zone, probably. But if you have like a more thread coming to a critical zone, then it might cause an issue. So it might happen. So one example, if I have a restaurant and the restaurant has only 3 seats inside the restaurant. So I can allow 3 customers coming to the restaurant and sit in the restaurant, right? But if I like allow like more than 3 customers coming to a restaurant, then I don't have a seat. So it's causing a problem. So this is possible, right? So in this case, we can use the semaphore. We can use like a multiple semaphore, like we call it a counting semaphore, to support the source code like this. But if you want to like protect the critical section, like for something like this one, you have to guarantee no other thread go into this critical zone when like some thread already inside. So in this case, we set the semaphore initialized value is 1 to protect it. So I have a question. You say use a semaphore is like use semaphore minus minus or plus plus this kind of value or like a while loop. Does this operation also cause this condition? Because minus minus can be in different like 3 lines of the assembly code, right? So if we use a semaphore minus minus, it still cause a rest condition, right? So why we can use semaphore to protect this? This is a very good question. Solex is a really good student in this class. Okay, so yes, it's correct. For the minus minus plus plus, these instructions in assembly is like separate to string lines. However, why we can use semaphore? If the semaphore is just follow this like a logic, try to do the minus minus plus plus or while loop. Because when we implement this semaphore, this system code, these functions, when we implement it, your CPU, your kernel already guarantee everything inside this function is executed by its own. So it won't be get interrupt. When I call same wait, it's never be interrupt. So in this case, your kernel can guarantee everything happened in this function won't be interrupted by your schedule. It will be execute, finish, then go to other schedule. So in this case, it can protect it. So for the same minus minus or same plus plus something like this, because your kernel guarantee this can happen, so you don't need to worry about oh, there's a rest condition for this same minus minus or rest condition for same plus plus, because your kernel already take care of for you. Okay. Now we already know how to use semaphore. So go back to the question we have: how to protect this critical zone? How to protect it? So actually, it's not so hard. We just add same way here, and after we count it, we add Semaphores here. Because same way means I take the key. So if I want to take a key, I don't have a key. I need to wait. I need to wait before the count plus plus. Then after I finish the count plus plus, I release the key to other thread. So in this case, you can avoid the rest condition. So this is the idea to use a semaphore. First one, we need to define a variable called SEMT by the type SEMT, and we pass the address of this. We pass the address of this first semaphore into initialize. In this case, we initialize the mutex equal to 1 because we only need 1 key. For this case, we only need 1 key. You can give like more numbers, but in this case, we only allow 1 thread going to a critical section. Then we can just use same way and same ports to protect this critical section, just like you have a door here and here to try to like avoid the thread going to this critical section. Okay, so this is the concept to use semaphore to protect your code to avoid the rest condition. So this is for today's video. We talk about how to use semaphore to protect your critical zone, how to avoid a rest condition. Actually, the semaphore itself is not so complicated. You can imagine that it's just a very like self-implement by your like kernel programmer. They can guarantee this function be executed by that itself. It won't be get any interrupt. So it can guarantee the value inside its update correctly. And you can use this to simulate a key and the door. So when you give the initialization value of the semaphore, how many key you want to give? If you say 5, means there's a 5 key. If there's a 5 key, means there's a 5 thread can go into this critical zone. So depends on the different application, you might like change this initial value of the semaphore. Okay, so when you call the same way, you like get the key. So which means you make the same value, the value of the semaphore to minus minus. When you call Semaphores, means you release a key. So you like increase the number of semaphore. So I hope this video can help you to understand how to like protect your critical zone when you write a thread program, multi-thread program in by your own. Okay, so I hope you enjoyed today's video. Semaphore is really awesome like stuff. You should consider to use it. Of course, in the future you will see like other good stuff like a mutex for you to like protect this critical zone. But the semaphore is the only one we cover in today's video in this course. Okay, so I hope you enjoyed today's video. See you next time. Semaphore is awesome.